students, welcome to JSM. In previous video, I have explained the introduction of hybridization and formation of hybrid orbitals. In this video, I am going to explain hybridization in molecules. Hybridization in molecules, that is organic and inorganic molecules. Organic and inorganic molecules. So, first one I am taking sp hybridization. sp hybridization. sp hybridization. Okay, sp hybridization. Okay, so right, what is sp hybridization? One s orbital, one p orbital combines to give one s orbital, one p orbital combines to give two sp hybrid orbitals. Okay, let us see, one s orbital and one p orbital. One s orbital, one p orbital combines to give two sp hybrid orbitals. Two sp hybrid orbitals known as what? Sp hybridization. Sp hybridization. Okay, so now this is a s orbital. S orbital. This is a p orbital. So now this is known as what? sp hybrid orbitals. sp hybrid orbitals. sp hybrid orbitals. How many total? Two are involving. One s orbital, one p orbital. Here we are getting two sp hybrid orbitals. Two sp hybrid orbitals. So now this is the notation of sp hybrid orbitals, that is hybrid orbitals. First example I am taking, inorganic example I am taking. First one is beryllium chloride. Beryllium chloride, BeCl2. So now in this beryllium chloride, central atom is beryllium. Its atomic number is 4. Electronic configuration 1s2, 2s2. Okay, this is 2s2 is outermost electronic configuration. Outermost electronic configuration. So now I am writing outermost electronic configuration of beryllium. So that is 2s2. We know that in second energy level there is a p orbital. There is a p orbital, that is vacant p orbital is there. This is 2s2 and this is 2p0. 2p0. So now this is known as what? Ground state electronic configuration. This is known as what? Ground state electronic configuration. So now here, whenever we give energy to this s orbital, this is the electron excited into p orbital. This process is known as excitation. Process is known as excitation. So now here it is the s orbital containing one and p orbital also having one unpaired electron. This is s orbital, this is p orbital. S orbital, p orbital. So now what is the hybridization? One s orbital, one p orbital. Okay, here we are getting two sp hybrid orbitals. Two sp hybrid orbitals. Two sp hybrid orbitals. Okay, so now at beryllium, how many sp hybrid orbitals? Two sp hybrid orbitals, and each orbital having one unpaired electron. So now I am writing beryllium. Okay, first hybrid orbital, and this is a second hybrid orbital having one unpaired electron in each orbital. Okay, so this is the hybrid orbital part of beryllium. Next, second element. Second element is what? Chlorine. Okay, so now chlorine, we know that chlorine atomic number 17, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. This is the outermost electronic configuration 3s2, 3p5, 1, 2, 3, 4, 5. This is px, py, pz, pz. So now in pz orbital we have what? One unpaired electron. How many chlorines are there? two chlorines are there. So that we are getting how many pz orbitals? 2 pz orbitals. 2 pz orbitals. Now, 2 pz orbitals of chlorine linearly overlaps with hybrid orbitals of beryllium. Hybrid orbitals of beryllium. Here you see again 2 pz orbitals of chlorine, which overlapping? Linear or axial overlapping hybrid orbitals of beryllium. So now this is the p orbital of chlorine. It is also p orbital of chlorine. So now formation of which bond? Formation of sigma bond takes place. Formation of sigma bond takes place. So now here, so now the structure of beryllium chloride is Be chlorine, and here also it is chlorine. Bond angle is 180 degrees and the shape is linear, or geometry is linear. So now in this beryllium chloride, how many sigma bonds are formed? 2 sigma bonds are formed. 2 sigma bonds are formed. So now this is the structure of beryllium chloride. So this is an inorganic molecule, beryllium chloride. So let us see organic molecule, that is acetylene. That is acetylene C2H2. Acetylene. In this acetylene, central element is carbon and its electronic configuration, atomic number is 6, electronic configuration 1s2, 2s2, 2p2. This is outermost electronic configuration. So now 2s2, 2p2, 2s2, 2p2. This is known as a ground state electronic configuration. Ground state electronic configuration. Simple. Whenever we give energy to this orbital, this is the electron excited into p orbital. P orbital. This process is known as excitation. Process is known as excitation. So in excited state, electronic configuration of carbon is 1, 2, 3. Okay, so this is known as first excited state electronic configuration. First excited state electronic configuration. So in excited state electronic configuration, how many orbitals are there? 4. One s orbital, 3 p orbitals. One s orbital, 3 p orbitals. So now here hybridization is what? 1 s orbital, 1 p orbital, so that we are getting 2 sp hybrid orbitals. 2 sp hybrid orbitals. 2 sp hybrid orbitals. Remaining 2 p orbitals having each one electron, and these are not involving in hybridization. So these are known as unhybridized orbitals. Unhybridized orbitals, or these are also known as atomic orbitals. Atomic orbitals. Okay, so now this is 1 s orbital, these are the p orbital. So 1 s orbital and 1 p orbital involving in hybridization, so that we are getting sp hybrid orbitals. How many? 2 sp hybrid orbitals for one carbon atom. So like that, how many carbon atoms we have? 2 carbon atoms, so that we are getting 4 hybrid orbitals for 2 carbon atoms. So first carbon atom I am taking here carbon. Okay, 2 sp hybrid orbitals. First hybrid orbital and second hybrid orbital. This is C1, first carbon atom, and this is first hybrid orbital of second carbon atom and second hybrid orbital of second carbon atom. So now each one having one unpaired electron. So now here it is linear formation, that is linear overlapping of hybrid orbitals. So formation of sigma bond takes place. Formation of sigma bond takes place. And this is the hybrid orbit also having what? Unpaired electrons. Unpaired electrons. So now this is the hybrid orbital part of carbon. Hybrid orbitals part of carbon. So now second element is what? Hydrogen. Okay, we know that hydrogen atomic number 1, electronic configuration 1s1. So in s orbital, how many unpaired electrons? 1 unpaired electron. So that how many hydrogens are there? 2. So that we are getting 2 s orbitals of what? Hydrogen. Okay, so now 2 1s1 orbitals of hydrogen which overlapping? Linear overlapping. Which overlapping? Linear overlapping. 2 1s1 orbitals of hydrogen linearly overlaps with hybrid orbitals of carbon. Hybrid orbitals of carbon. So that here this is the s orbital of hydrogen. S orbital of hydrogen which overlapping? Linear overlapping. So which bond formed? Sigma bond is formed. Sigma bond is formed. Okay, so now hybrid orbitals part completed and second element part also completed. So remaining orbitals are what? Remaining unhybridized orbitals or atomic orbitals are pure p orbitals. Pure p orbitals. So now that is what? Here it is a p orbital, that is px and py. First one I am writing, that is first p orbital. Okay, here first p orbital of second carbon atom. Right? So now second p orbital. So that is second p orbital. So these orbitals also having each one electron. So now py orbital, these two are pz orbital. So there is no chance to overlapping of what? Linear overlapping. Okay, so there is no linear overlapping in case of py and pz. So which overlapping is possible? So lateral overlapping is possible like this. Lateral overlapping is possible in case of these py pz. So now which overlapping? Lateral overlapping, not linear overlapping. So now here it is the formation of pi bond takes place due to which overlapping? Lateral or parallel overlapping. So now here it is what? Between py and pz. Py and pz. So in case of formation of pi bond, half of the electron cloud is above the plane and remaining is below the plane. So now here between two carbon atoms already one sigma bond is formed. So now how many pi bonds? This is the pi bond and this is also pi bond. So total 3 bonds are formed between two carbon atoms. Between carbon and hydrogen, how many? Single bond. Here also between carbon and hydrogen, single bond is formed. Okay, so what is the bond angle here? Bond angle is 180 degrees. And geometry? Linear geometry. Okay, in the formation of acetylene molecule, how many sigma bonds? Here 1, 2, 3. So how many sigma bonds? 3 sigma bonds. How many pi bonds? 2 pi bonds are forming in the formation of acetylene molecule. So now how we know which is pi bond and which is a sigma bond? In the formation of a molecule, single bond is always sigma bond. In a multiple bond, one should be sigma, remaining all are pi. Say for example, this is a triple bond between two carbon atoms. One is sigma, remaining two are pi bonds. For example, between two carbon atoms, double bond is there. So one sigma and one pi. So this is the formation of acetylene molecule.